Have set up our working environment in the previous video. We are ready to talk to Claude. The official course has a lesson called Making a Request, and it covers the basics pretty well. How messages.create works, what parameters it takes, what the response object looks like. If you haven't yet watched it, it's worth 5 minutes. What we are going to do here is look at how the same concepts land in TypeScript, and specifically at the abstraction layer we've built in our shared.ts file. Let's start with the lesson file o1makingarequest.ts. We start with an empty array of messages, add a question, call Claude, add its response back into the conversation, then ask a follow-up. That's the entire pattern for multi-turn conversation with the API. Now let's take a closer look at each step. We import message param type from shared types.ts, but we didn't invent it, it's just a re-export of the type defined in Anthropic's SDK. The official course describes a message as an object with two attributes: role, which can be either user or assistant, and content being a plain string. That might be good enough for this lesson, where we only exchange simple text messages. In reality, though, this is only a slice of a broader message param type, defined by the SDK, which we re-export in shared types.ts. We'll need the full type in later lessons anyway, so we adopt it from the start instead of replacing the simplified version later. And although the message param type might be more complex, TypeScript will catch any misuse for us anyway. Now let's have a look at addMessage functions in shared.ts. Both functions push a new item onto our messages array. It's worth noting that push mutates the array in place. You might be familiar with the spread syntax in JavaScript, like this. This creates a new array rather than modifying the existing one. If you work with reactive frameworks like React or Svelte, then immutability is important and that pattern is justified. Here, reactivity is not a concern, so push is just more efficient. Notice that content parameter is typed as content in message param rather than a plain string. That's the same forward-looking point as before, just baked directly into the signature to align with the SDK from the start. Message param's content can be a plain string or an array of content blocks. In this lesson, we only pass a string, but the type is already there for when later lessons need more than that. The actual API call lives in the chat function. This is a wrapper around clients.messages.create, passing the parameters described in the official course: model, token limit, and the message history. We apply the max tokens ceiling from the settings.ts here. As the official course explains, Claude won't try to reach it. It just stops if it does. Ignore tools, system, and temperature for now. They're grouped into a single chat options object rather than 3 separate parameters, which helps us keep the function signature stable as the course introduces each one. The call returns the full response object of type message defined in the SDK, which on top of the message content also contains other details like stop reason or usage statistics. The chat text function abstracts that complexity and just returns the model's response as a string, since early in the course this is all we need. Now the text from message function handles the extraction. The official course takes a shortcut here, extracting the text from the first content block directly. But eventually it comes back to properly aggregating textual content, similar to what we do here. We just do it from the start. The content array can contain blocks of different types, and we'll see that later in the course. We print out our messages array with console.log throughout the lesson, so you can watch the array grow. This is the full conversation history being sent to the API on every call. It's important to understand that Claude doesn't maintain state or memory between requests. This is why we are resending the entire context each time, and that's how continuity is preserved. Run npm run dev command in the terminal, select this lesson, and you should see our messages array followed by Claude's response printed out at each step. The answer to write another sentence will reference the quantum computing definitions from the first turn. That's the conversation history doing its job. Otherwise, the response would be completely unrelated. If you want to see that, uncomment the line resetting the message array and rerun the lesson. So, we have made our first real API call and seen how the conversation history builds up from one turn to the next. Now let's take the same pattern and wrap it into a loop for a live back and forth chat with Claude. That's the chat exercise we will look at in the next video.